Okay, so today we're going to learn about experimental probability. We've done theoretical probability yesterday, so I'm going to kind of talk about the difference between the two and then just specifically talk about experimental probability. So the experimental probability of an event is found by comparing the number of times the event occurs to the total number of trials. So when there is only one outcome for an event, that is called a simple event. So we're going to use this spinner above over here in order to find the experimental probability of spinning a 3. Now, in order to find the experimental probability, it's similar to the theoretical probability, in which we use the formula, we use the ratio, I should say, number of times the event occurs over the total number of trials. Okay? So, if this was theoretical probability, the probability of rolling a 3 here would be, what's our total possible outcomes? There's 4. 1, 2, 3, 4. So it's something out of 4. How many times can we roll a 3 in this situation? We could roll a 3 one time. So the theoretical probability is what's supposed to happen. So if I roll it 4 times, I'm supposed to get a 3 at least once. Okay? That is theoretical. Now for experimental probability, I actually have to spin the spinner and go through trials. After I go through trials, then I could go ahead and create my my experimental probability. Now keep in mind, the experimental probability may not be the same as the theoretical probability, so it's good to know the difference. So I have a spinner right here, so I'm gonna just go ahead and spin it. So I rolled a 3, I rolled a 2, I spun a 2, I spun another 3 just now, spun a 1, spun another 2, right? Spun a 1, spun a 3, another 1, another 1, and then a 3. Okay? So, number of times I spun the 1, 3 times. Number of times I spun a 2, 2 times. Number of times I spun a 3, 4 times. And the number of times I spun a 4 was just 1 time. Okay? So as you can see, I created a little table here in order to help organize my data. Now I'm just going to do the fraction total. So how many times did I roll it? I rolled it 3 plus 2, which is 5, 5 plus 4, which is 9, 9 plus 1 is 10. So out of 10 times. I rolled the 1 3 out of 10 times. I rolled the 2 2 out of 10 times. I rolled the 3 4 out of 10 times. And then I rolled the 4 1 out of 10 times. So, the probability here, the experimental probability of rolling a 3 here would be 4/10, which then simplifies to 2/5. So as you can see, I'm just going to put P underscore E. For my experimental probability, finding a 3 was 2/5. For my theoretical probability, PT, for finding a 3, that's going to be 1/4. So remember, theoretical is what's supposed to happen. But experimental is what happens when you go through trials and you actually do an experiment in order to figure out the probability. Now, let's go over one more example. Martin has a bag of marbles. He removed one marble, recorded the color, and then placed it back into the bag. He repeated this process several times and recorded his results in the table. Find the probability of drawing each color. Write answers in simplest form. So, if it already gives you data with stuff filled out, you're probably trying to calculate the experimental probability as opposed to the theoretical probability, like this case right here. So the first thing I'm going to do is I'm going to figure out what is the total frequency, what is the total number of trials. So 12 plus 10 plus 15 plus 13 is going to give me a total of 50 total trials. Okay, so with that 50 trials, let's go with red first. So the number of times red occurred was 12. The total number of trials was 50. So this simplifies to 6 over 25. Now for blue. The frequency of the blue is going to be 10. The total amount of trials is 50. So this simplifies to 1/5. Next we have green. The frequency of the event, how many times green occurred, was 15. Total, of course, is 50 again, so this simplifies to 3/10. And then lastly, for yellow, the frequency of the event yellow was 13, and the total amount of trials was 50. So this is the experimental probability for all of the colors. Okay? That's it.